Okay, greetings, guys. This is a walkthrough of the rational functions practice test. I'm just going to go quick through each question. If you need to slow it down, decrease the speed, or replay some things. Okay, so simplify each expression, problems 1 through 6, include restrictions. So to simplify the expression, remember, you're going to have to factor, list the restrictions, and cancel common factors. So first thing I look for factoring is common factor. I see one here, 10 and 70. 10 goes into both of those. If I factor 10 out, I get 10k divided by 10 is k, negative 70 divided by 10 is negative 7. On the bottom here, it's a trinomial, so I'm going to put a couple sets of parentheses. I quickly notice there's no common factors. I'm going to have a k and a k. Factors of 7 that add up to 8 are going to be a negative 1 and a negative 7. Okay, so restrictions for a second. K cannot equal 1 because 1 minus 1 equals 0. And 7 because 7 minus 7 equals 0. K minus 7 cancels, and I'm going to have 10 over k minus 1. So there is my answer. Okay, number 2. 2 is multiplying, so it's exactly the same as simplifying, except anything on top, no matter where, can cancel anything on bottom. So I'm going to factor x squared minus 25. That's a difference of two perfect squares. Just going to set myself up that. The square root of x squared is x, so that's there and there. The square root of 25 is 5, so it's plus 5 and minus 5, right? Yeah. At 2x minus 4, common factor. 2 and 4, a 2 will divide into each of those. 2x divided by 2 is x. Negative 4 divided by 2 is negative 2. Okay, 6x plus 36. 6 and 36, 6 goes into both of those. 6x divided by 6 is x. 36 divided by 6 is 6. And in each case, I'm noticing there's no powers, there's no more common factors. That's how I know. So I'm continually double checking, double thinking, am I done? Am I done? Or can I go further? X squared plus x minus 30, there's no common factors, and it's a simple trinomial. So x and x, factors of 30 that subtract to make 1, positive 6 and negative 5. Now, along the way, guys, I noticed there's an x plus 6, so I threw that down, and I was pretty sure that was going to work, and it did. Okay, now, restrictions. Each factor that has an x will have a restriction. This one will not, because 2 will never equal 0. Here, 2 minus 2 will equal 0, so x can't be 2. Here, negative 6 plus 6 will equal 0, so x can't be negative 6. Here, 5 minus 5 will equal 0, so x can't be 5. Okay, x plus 6 cancels. X plus 5, nope, there's no x plus 5, but there is an x minus 5 there and there. 6 and 2. 6 will reduce the 2 and make it 3. Always consider the numbers. Consider every factor. So x plus 5, no. Well, there's only the x minus 2, and that's it. So it's 3 times x plus 5 is left on top, and x minus 2 is on the bottom. So that is it. Cool. Okay. Next problem, division. So I'm going to factor everything because I'm going to have to factor eventually, and it's going to be easier here. 2x squared minus 5x minus 3. So I'm going to factor that. X squared plus 4x minus 5. So that one's easy. I skipped the top because it looks a little harder. X squared is going to be x and x. Factors of 5 that subtract to make 4. Let's do a positive 5 and a minus 1. Right? Yeah. Okay. Now to the top. I'm going to 2x and x because that's all there will be. That's all there is to make 2x squared. 3. So it's either going to be a 3 and a 1 or a 1 and a 3. Well, I'm thinking for a moment. Suppose it's 3. Then I have 3 times x and 1 times 2x. 3 times x and 1 times 2x. That might work. Oh, but they would have to be the same. So let's do a 3 here and a 1 there. And it's a negative 3, so one of these has got to be positive, one's got to be negative. I think it's going to be here and here because I notice 2 times 3 is negative 6, and 1 times x is 1x. 6x, negative 6x plus x is there. So that's right. Okay, now, divided by. when you divide fractions, I'm going to do two things at once here. When you divide fractions, I've got to take this and flip it. So in other words, this 3x plus 15 is going to go on top. Well, but that has a common factor of 3. So I'm going to factor that out, and it'll give me an x plus 5. This was the top, so it's going to be flipped to the bottom. X and x, factors of 21 that subtract to make 4, positive 7, negative 3. Okay, that's it. Now, so a couple of things. Factor everything. When you're doing division, flip this second denominator. So this 3x plus 15 was on top. Now it was on the bottom. Now it's on the top, and vice versa. When you're listing restrictions, think about all the denominators. This denominator, and this used to be in the denominator here, so it will have restriction. So 1 minus 1 will make 0, so x can't be 1. Negative 5 plus 5 will make 0, so x can't be negative 5. Negative 7 plus 7 will equal 0, so x can't be negative 7. 3 minus 3 will equal 0, so x can't be equal 3. And here, negative 5 plus 5, but I've already got negative 5, so I don't need to worry about it again. 3 will never equal 0, so not worried about it. Okay, now I already noticed the x plus 5, so I'm going to cancel that. 2x plus 1, not here. That's gone, not here, not here. So that's good. X minus 3. There's an x minus 3 on the bottom, so that cancels. 3, no. So all this has is 3 times 2x plus 1. This is all that's left, all over x minus 1 times x plus 7. That's it. Cool. Now. Okay, adding, subtracting fractions. You got to remember what my big, fat, hairy, cigar-smoking 4th grade teacher told me. When you are adding subtracting fractions, they must have a common denominator. This does. So I know I can combine these, and it's going to be over the same denominator. So it's going to be over 4x squared minus 49. And I've got 4x minus 14. Okay, now I've got to consider, can I cancel things? Well, 4 and 14, 2 divides into each of those, and I'd have 2x minus 7. This is a difference of two perfect squares, because the square root of 4x squared is 2x and 2x. The square root of 49 is 7 and 7. So I go, oops, that's going to be a minus 7. That's a minus. Okay, so now restrictions, x can't equal. Here it's going to be negative 7 over the 2. Here it's going to be positive 7 over the 2. 2x minus 7 cancels 2x minus 7, and I'm left with 2 over 2x plus 7. So since they had a common denominator, all I need to do is subtract the numerators. That's what I did here. And then consider, can you simplify? Yikes. Okay. What about this one? Number 5, adding. They don't have common denominators, so I'm going to factor everything here. Hopefully I can find an easy common denominator. 3x minus 12. 3 goes into each of those, and I would have x minus 4. Okay, plus 6, 2x minus 8. 2 factors, and I'd have x minus 4. But now I notice something. See how this 6 and the 2 will reduce? I'm going to reduce this right now. Okay? Now, check this out. These don't have a common denominator. This has a 3. This one doesn't. So I'm going to multiply by 3, top and bottom. Okay? This has an x minus 4. So does this. So now, look, the denominators are the same. 3 times x minus 4, 3 times x minus 4. Now, if you didn't cancel out that 2, I'd have to multiply a 2 over here, top and bottom. But I'll tell you, it's easier to reduce first, I think. So now the denominators are the same. It's going to be both over 3 times x minus 4. And I've got 2 plus 3 times 3. 3 times 3 is 9. 2 plus 9 is 11. Nothing there is going to simplify. And so that's it with my restrictions. 3 won't ever equal 0, so that's not going to have a restriction. But x minus 4 will. X can't equal 4. because 4 minus 4 makes 0. Cool. Okay. Now, 6. Denominators are not the same. So I'm going to factor this for a second. 3 all over x squared plus 4x plus 3. It's a trinomial, and there's no common factors. So it's going to be x and x. Factors of 3 that will add up to 4 are positive 3 and a positive 1. Okay. Plus, I've got 2, and this will factor x squared. So it's just x and x. Factors of 6 that subtract to make 1. How about a positive 3 and a negative 2? Okay. Now I got to find common denominators. So I'm thinking about this. This has an x plus 3. So does this one. Good. This has an x plus 1. This does not. So I'm going to multiply by x plus 1 on the bottom and on the top. And I know I'm kind of squishing it in there, but oh well. Yeah, that works. So x plus 1, x plus 3. So far those are the x minus 2 is here, but it's not over here. So I multiply top and bottom by x minus 2. So now check out what I've got. On the top, I've got 3 times x minus 2 plus 2 times x plus 1. And it's all over x plus 2 times x plus 3 times x plus 1. Good. Okay. So that's how I find the common denominator. Consider the denominators factor by factor, and whatever factors are missing from one, multiplying by the other. This one was missing an x plus 1. So multiply it over here. This one was missing an x minus 2 from there, so I multiplied there. Now, 3x minus 2, that's 3x minus 6. 3 times x, 3 times 2, right? 2 times x is plus 2x. 2 times 1 is plus 2. Combine, and those are all going to be over the same things. 3x plus 2x is 5x. Negative 6 plus 2 is negative 4. That's not going to factor. So I know it's not going to simplify. So that's it. And x can't equal negative 2 because negative 2 plus 2 equals 0. Negative 3 because negative 3 plus 3 equals 0. And negative 1 because negative 1. Oh, that's not a plus 2. That's a minus 2. Okay, I got it there. But this should be a minus 2 right here. That's a minus 2, which means x can't equal positive 2. Okay, there that is. Now, let's look at some solving things for a second. Solve each equation. So to solve each equation, remember, I need to make sure they have the same denominator. And then once they have the same denominator, I find the restrictions, and I ignore the denominators after that. So, there's a 1 there. Okay, this has a 5. This has a 5. This doesn't, so I'm going to multiply by 5. This doesn't, so I'm going to multiply by 5 there. Okay? I'm going to zoom in a little bit more. I'm sorry, that'd probably be a little easier to see, huh? Okay, I guess you guys can zoom your computer out, huh? Yeah, you can. So 5x. So this doesn't have an x. I'm going to multiply by x, top and bottom. This has a 5x. This doesn't, so I'm going to multiply by x, top and bottom. So now look at my denominators. 5x, 5x, 1 times 5x, which is 5x, 5x. So my denominators are all the same. Now check this out, restrictions. 5 times what makes 0? Well, 0, so x can't be equal to 0. I have to keep that in mind. Now, here I've got 3 times x plus 1 equals negative 2 times x plus 4 times 5 is 20. Okay, cool. Let's add 2x to each side. That's gone, and I get 5x plus 1 equals 20. Subtract the 1 from each side, and I get 5x equals 19. And then if I divide by 5, I get x equals 19 fifths. And all I have to do is compare that against my restrictions. It's not 0, so that's not extraneous. So I'm good to go. Cool. Move on to the next one. Okay. I'm going to have to factor this out. So I'm going to have 2 x minus 3x plus 2, because x times x makes x squared. Negative 3 plus 2 makes negative 3 plus 2 makes a negative 1, and negative 3 times 2 makes a negative 6, equals 4 over x minus 3. And I'm already seeing commonalities. X minus 3 plus 4 over x plus 2. But I notice differences. X minus 3, no x minus 3. So I'm going to put an x minus 3 here. Now these are the same, but this is not. Because see, x plus 2, this one needs an x plus 2. Okay, now I've got that. Let's think about restrictions. X cannot equal 3 minus 3 makes 0, so 3, and negative 2 plus 2, negative 2. And I end up with 2 equals 4 times x plus 2, that's 4x plus 8, plus 4 times x minus 3. 4x is 4x, and 4 times negative 3 is negative 12. Cool. Oh, I forgot an x there, right? Check again. 4x, 4, 2, there's 4x plus 8. 4 times x, 4 times negative 3, 4x minus 12. Perfect. So I've got 2 equals 4x plus 4x is 8x. 8 minus 12 is negative 4. Cool. And if I add 4 to each side, I get 8x equals 6. And then if I divide by 8, I get x equals 6/8, which is the same as 3/4. And that's not on my list of restrictions, so that's good. That is the first page. Okay. On to the second page. Another video. See you on the second page.